Alright class, so we're going to start the Chapter 9 review. On page 248 we're going to work on numbers 11a and 11c. Now we are talking about moles, molar mass, and Avogadro's number. So we're going to be doing conversions between these three things, and we're going to use the values that we know, Avogadro's number being 6.022 times 10 to the 23rd, the molar mass being the molar mass of whatever element or whatever formula that we're going to be using. And then obviously knowing that moles are going to be that specific amount, which we say is 6.022 times 10 to the 23rd. Okay, so let's start with number 11 and letter A. It asks how many moles are in 37 grams of iron. Okay, so right off the bat, what I want you guys to do is I want you guys to create a little tiny flow chart just like this. Okay, so I made one. Take a good look at it. This is basically your bridge notation, just all summed up into one. So this will help you a lot. Take a good look at it, make one as similar to this as possible. Basically, we have moles right smack in the middle. We say that we always basically go back to moles. There's no way to go from atoms to mass without passing through moles. To be able to get from atoms to moles, we're going to have to do something with Avogadro's number. Okay, we're going from atoms to moles. We're going to be multiplying by this fraction that we have here. Basically 1 mole of whatever it is over Na. Now Na is going to be Avogadro's number, which we know is 6.022 times 10 to the 23rd. Now let's say we're going from moles to mass. Now we're going to use the mass from the periodic table. That's what mass from PT means, okay? So I want you guys to make sure that you have not only this, but that you also have a periodic table that you can use and that's available to you. The one from your book is great. So go ahead and make sure that you have 1, the periodic table available, and 2, pause this video if you need to and make a little flow chart just like this, okay? It will help you a lot. I'm going to explain in these videos how to do it, and I promise you it'll cut your time in half because you're not going to be wondering what you need to do, okay? So let's look at what this gives us and let's use this little flow chart to help us out. So how many moles are in 37 grams of iron? Okay, now the problem originally says how many moles of iron are in a 37 gram sample of iron. Remember, Fe is iron. So all you need to do is find out where you're starting from and then figure out where you want to end up. Okay, so this problem is asking us how many moles. Alright, so we know that we want to end up in moles. This is our end point. But we're starting in 37 grams of iron. So we're basically going from mass to moles. So we follow these arrows, right? We're going from mass to moles. All we're going to need to do is set up a bridge notation, right, where we have moles on the top and the molar mass of whatever element, which in this case is iron, on the bottom. Okay, now this will make sense when I set it up. So we're going to go ahead and set up a bridge. Now I drew this bridge down here so that you guys can see. Basically, your bridge is either going to have, in these types of problems, either going to have 1 column or 2 columns. Okay? In the case that you're just going from a side to the center, you are only going to set up 1 column. Okay? In the case that you're going from one end to the other, you're going to set up 2 columns. Now let me tell you what I mean. Okay? So we're going from grams to moles. All we're going to have to do is go ahead and set up a bridge with 1 column. Okay? Now we're starting with mass, right? So that's the first thing that you're going to write in there. Okay, we're going to go ahead and write this 37 grams. So we have 37.0 grams of Fe, and I want you guys always to write down the unit and write down the atom as well, the element, whatever it is that you're using. Remember that we start off with something over 1, okay? Then whatever goes in here is just going to be a conversion factor. We don't have to guess what that conversion factor is going to be because we wrote it right here. Basically, if you're going from mass to moles, you're going to multiply by 1 mole over the molar mass of whatever the element from the periodic table is. Remember, your end goal, you want to finish off with moles, right? So you're going to have to cancel out this grams, all right? So you know that on the bottom here, you need grams, and at the top here, you need moles of Fe. Okay, now the molar mass is just that, right? It's a gram per mole, or if you're flipping, it's the moles per gram. 1 mole of Fe is going to be how many grams? How do you figure that out? You go to the periodic table. In the periodic table, you can find Fe, which is iron, and you can see here that it says 55.845. Now your periodic table in your book doesn't go that that precise, okay? Your periodic table only goes to 4 significant digits, but that's totally fine. That's all that you need, okay? So I'm actually going to go ahead and round it so that it looks like what you have on your periodic table, okay? And I'm going to put 55.85 grams of Fe. So now all we have to do is do the operation and cancel out whatever we don't have. Sorry, whatever gets to be canceled out, okay? So here we have 37 grams of Fe. This grams of Fe is going to cancel out with this grams of Fe. So we're going to be left with the moles, which is exactly what we want, okay? So we're going to go ahead and use our calculator to figure it out. And remember that with these types of problems, you can just plug it straight into the calculator. So we have 37.0 grams of Fe. We don't need to worry about the units, divided by 55.85. Okay, and that's going to give us 0.662. And sorry that I wrote it a little bit weird, but remember to include a good amount of significant digits in the beginning, okay, because you are going to have to round at the end. So we have 0.662489. Okay, now how many significant digits can we use? We have to go ahead and we have to look at our original value, right? Remember, we don't use conversion units, okay? We don't use this right here. It's just a conversion unit, okay? It's what we're using to find the final answer. We have to look here. Here we have 3 significant digits. So that means that here in our final answer we can only have 3 significant digits because it's a multiplication problem. Now if we're going to have 3 significant digits at the end, what we want to go ahead and do, let me go ahead and get this, is that we only want 3 significant digits, which means we have to round to this place right here. So how do we round? We look to the next digit, and if it's 5 or more, let it soar. 4 or less, let it rest. So this one is 4 or less, so we are letting it rest, and your final answer is going to be 0.662 moles of iron. Okay, that's your final answer. Okay, so that's not a difficult problem, especially if you have this little flow chart. Let's move on to this one. Okay, it's a little bit different, but still not difficult. How many moles in 3.25 times 10 to the 26 formula units? Now, do not be tricked by this word right here, formula units. Okay, I wrote it here as well. It may be a little bit blurry. I don't know if the document camera can get this, but it says units right here. Anytime they're talking about atoms, molecules, or units, it's basically the same thing as atoms. Okay, so it's on this left side. All right, how many moles are in this many atoms of sodium iodate? Okay, same exact thing you're going to do. Let's figure out where we start and where we're going. So we are starting with the formula units, right? We're starting right here, and we want to go to moles. So we're going from here to here, which means we're going to follow the top path, and we're going to set up a bridge notation of only one column, right? Only one column, where we are going to have the conversion factor be something that is 1 mole over Avogadro's number. So let's go ahead and let's set up that bridge notation right here. We can do it a little bit bigger. Okay, so we start off with the atoms that they gave us. 3.25 times 10 to the 26 units, I'm just going to write units, of sodium iodate. Okay, over 1. And now what are we going to use? We're going to use this conversion factor that we have right here, 1 mole over Avogadro's number. Basically, all that's saying is that 1 mole of sodium iodate is going to be 6.022 times 10 to the 23rd atoms or units of sodium iodate. Why don't we say the word atoms? Because this is a formula. Okay, so since it's a formula, we have to say formula units. Okay, so basically 6.022 times 10 to the 23rd units of sodium iodate. Okay, and now that's not a difficult calculation either. Okay, so we can just go ahead and plug it into the calculator. All right, we set it up correctly. Let's make sure that everything cancels out. We started with units. We can cancel out units. We want moles. That's what we're going to have at the end. Okay, so 3.25, and then remember that the best way to do the exponent is to just do the second value right here, second, and then you go right here to the superscript e, and then you get a little e right there. So 3.25 e 26, that means to the 26th power, and you can go ahead and just press enter, and you can see that it says times 10 to the 26. It's a little bit blurry, but try to follow along with me here. Divided by 6.022 E23. Okay, and now all this is saying is that this many atoms or this many units of sodium iodate is going to be how many moles of sodium iodate. Okay, so since this number was obviously bigger because times 10 to the 26th than this, we're gonna expect to have more than 1 mole. Okay, and in fact we have much more than just 1 mole. We have 539.6878. Let's go ahead and let's write that down. 539.68, and we could just round here 8 times, and let's not forget, nope, that's it, there's not times anything. Okay, so this is the answer that we got. Okay, but is it the right amount of significant digits? So how many significant digits do we have here? Here we have 3 significant digits. That means that our answer can only have 3 significant digits. Therefore, we can only go up to this value right here, which means we look right here. 5 or more, let it soar. This is 5 or more, so we're going to let it soar, which means that this value is going to go up, which means that our final answer is going to be 540, period, so decimal. And why do we need to add that decimal here? Because if we only wrote 540 without the decimal, then we would only have two significant digits, because remember that trailing zeros are never significant unless you have that decimal. So 540 moles of sodium iodate. Okay, and that's the final answer for that. So that's number 11. We're going to go ahead and move on in the next video to